Okay, guys. So today we're gonna look at one of the last two tests in this semester. You guys are almost there. This test is called chi-square test. And before I show you guys the computations of this chi-square test, I want to give you guys some information about when are we gonna use this chi-square test. At the same time, I also want to give you guys a brief summary of the tests we have learned so far and will learn in the next couple of weeks. So let me show you this visualization I made for this summary. We can see that this visualization has two columns here and two rows here. So we can see that for predictor, we have categorical variable such as gender, ethnicity, hair color, you name it. At the same time, we could also have a continuous predictor such as age, weight, and height. So these two columns are they represent the predictors, possible predictors. At the same time, we also have these two rows. The first row represents what kind of outcome variable we have. The first one is a categorical outcome variable, such as your career choice, such as you want to go to academia by getting a more advanced degree, or you want to go to a company and enter into the industry field. So it's a categorical variable. It is either or. And another possible outcome variable we could have is a continuous one, such as your salary, right? So you can take your salary can take any number, ranging from 0 all the way up to, I don't know, 10,000 or even 100,000. So we have these two columns, two rows, and let's look at these intersections. So with these two possible predictor types and two possible outcome types, we could have four possible situations. We're going to use four different tests given a certain type of predictor and a certain type of outcome variable. Let's take a look. So we're going to start from this first one. When we have a categorical predictor, at the same time we have a categorical outcome variable, we're going to use this chi-square test. And this is our main topic for today's class. Let's say, let me give you one example. Let's say we want to say whether gender would make a difference in people's career choice, right? Such as I'm wondering whether men are more likely to go to industrial than women, or the other way around. So in this situation, we're going to use this chi-square test when we have a categorical predictor and also a categorical outcome. Okay, so let's move to this blue or green box. So this is a test called logistic regression. When are we going to use this test? That is when we have a continuous predictor, but we have a categorical outcome variable. Let me give you one example. So let's say I want to say whether people's weight or height would influence their career choice. So we can see that this possible predictor we are proposing here is weight or height. It is a continuous variable. And we want to see whether this continuous variable has any influence on people's career choice, which is a categorical variable. And in this situation, we're going to use something called logistic regression. But this is a really advanced test, so we're not going to cover this topic or this test in this semester's course. But if you're going to do some relevant test, or you're going to do a logistic test for your thesis or for your term project or whatever, feel free to come to me and I'll give you guys probably a crash course. Okay, so that is the first two tests. Let's move to this corner. And when are we going to use this test? That is, we have a categorical predictor, such as gender, ethnicity, hair color. At the same time, the outcome is a continuous variable, such as salary. So what are we gonna use? What kind of test we're gonna use for this situation? We actually have covered this all the tests here in this box. I'll pause here, and probably you guys want to kind of try to come up with the answer and see if you can get the correct answer. If your answer is t-test or f-test, you are getting super close. And if you say t-test and f-test, bingo, that is the correct answer. T-test and f-test are used when we have a categorical predictor and a continuous outcome variable. Let's say the examples I showed you guys in the class is whether different courses would lead to different levels of stress. So apparently, these different courses people are taking is a categorical variable, that is our predictor. And our outcome, which is the stress level, is measured as a continuous variable ranging from 1 to 9. But when we use the t-test, when we use the f-test, it's decided by how many groups we are comparing between. Let's say if we are comparing between two groups, we're going to use a t-test. And depending on whether we have these data points from the same person or not, or these two groups are independent, separate or not, we are using the parity test or the independent t-test. And if we are making a comparison between more than two groups, such as 3, 4, we are use this f-test. So this is kind of we are pretty much done with this box. We've covered all the tests in this box. So let's move to the last box here. That is a test we're gonna use when we have a continuous predictor and also a continuous outcome variable. This test is called correlation analysis. This is a very commonly used test in scientific research. And we're gonna talk about this test in next week's class, which is very important. So this is a summary of all the tests we've learned so far, and I hope this can give you a clear picture or clear summary about all the tests and some directions or some guidance about which test to be used given a circumstance. Okay, so let's talk about this chi-square test. And first, I still want to start talking about this test by giving you guys a concrete example. So let's say I have a research question here in my mind. My research question is whether gender would make a big difference in people's career choice. So we have two genders, males and females. And for career choice, I have two big categories, academic or industrial. That is whether people want to pursue a more advanced degree after graduation, such as a master's degree or even a doctorate degree, or they want to go to a company and land a job in the industrial field. So two big categories, right? Academic or industrial. And this is the outcome variable we're looking at. And the predictor we propose here is the gender, still a categorical variable, either male or female. So to answer this question, I recruited 93 participants or students from our Webster campus. So among these 93 students, we have 49 males and 44 females. And I asked their career plans. Among these 49 guys, 13 of them would pursue a more advanced degree after graduation, and 36 plan to land a job in a company. And among these 44 females, 14 of them, they want to get a master's degree after graduation, and 30 of them want to land a job in a company. So in total, we have 27 people, including both males and females, would like to pursue a master's degree or doctorate degree after graduation, and 66 of them want to find a job in industrial field. Okay, that is the data for these 93 participants. So by just looking at this sample, it seems that the guys, they tend to go to the industrial field because we have 6 more guys in industry compared with these 30 females in industry. But we're not just interested in this sample, we're interested in the population behind this sample. That is, why the gender difference exists in people's career choice in this general population, right? We want to make some inferences about the behind population from this sample. So again, the essential question we are asking here is whether this difference, okay, between males and females, this difference is large enough so that we can claim there is a true difference in the general population, or it is just an observation bias. Okay, so let's all together take a look at this chi-square test to make a correct decision. So still first, the logic or the general procedure for chi-square test. The logic is very similar with F-test or T-test. So first, we're gonna build the null hypothesis, assuming that gender does not influence people's career choice. And based on this null hypothesis, we're gonna calculate a value called chi-square value. And then we want to kind of compare this obtained chi-square value against the critical chi-square value in the chi-square table. And last, we want to make a decision if our obtained value is larger than the critical value. We're gonna reject the null hypothesis, claiming that gender influences people's career choice. But if it is smaller, we say that we're gonna return this null hypothesis, because assuming that this null hypothesis is true, the probability of getting such a value is very normal, is very likely. So we're gonna return the null hypothesis. So this is kind of the entire population to do a chi-square test. And since I believe that you guys are also familiar with this whole procedure, null hypothesis, comparing the values and make the final decision. So I'll quickly pass the rest part. I'll just focus mainly on this part, the second step, how to calculate this chi-square value. This part is very easy. I promise you guys that we can get it done within 15-20 minutes. So let's take a look at this chi-square test or chi-square value computation in next video.